A database's vault turns Nodus into a place to keep structured records, rows, columns, and everything you can compute from them. Each database is its own entry in the sidebar, with search, analysis, and data chat underneath. This one is a museum catalog, 40 pieces, and a second table listing the rooms they are displayed in. The table is the workspace. Rows are records, columns are properties, and every cell is edited in place. There are 15 property types. We will go through all of them, because which one you choose decides what you can ask later. Title is the name of the record. Every table has exactly one, and it is what other tables show when they point at this row. Text is free writing, from an inventory code to a paragraph of notes. Number holds figures, and only numbers can be averaged, correlated, or plotted, which matters more than it sounds. Here, the year, the height, the conservation hours, and the valuation are all numbers, so all four are available to the statistics later. Date records, when something happened. It is what lets a time series exist at all. Time is a clock reading on its own, without a day attached, like the hour a gallery opens. Select is one value from a fixed list. Because the list is closed, the values can be counted and compared. Each option carries its own color, and you manage the list from the column itself. Multi-select is the same idea when a record can hold several at once, like the techniques used to make a piece. Checkbox is a plain yes or no. 2/3 of this collection is on display. Attachment holds files. Here, every piece carries a photograph and a picture of its accession label. They are stored inside the vault, not linked from somewhere else, so the catalog stays whole if the originals move. Relation points a row at a row in another table. Each piece points at the room it is shown in. And that other table is a normal database of its own, with its own columns. Rollup reaches along a relation and brings a value back. This one carries each room's capacity onto the piece. A rollup can list the values, count them, or take their sum, average, minimum, maximum, or range. Comparison is the unusual one. It reads several columns that answer the same question and writes down the value most of them agree on. 3 people attributed each piece: the catalog, the curator, and the laboratory. Where they agree, the answer is filled in. And where all 3 disagree, the cell stays empty rather than picking a winner. A blank here is a finding, not a gap. Formula computes a value from the other columns, and it is built from a recipe rather than typed as code. There are 4 recipes. The first is arithmetic. Value divided by height gives what each centimeter of this collection is worth. The second compares a row with the whole column, what share of the collection's total value each piece represents. The third is a rule. If the valuation is above 70,000, it is band A, above 30,000 band B, otherwise band C. Each branch paints its own cell, so a column of rules reads as a traffic light down the table. And the fourth joins columns and fixed text into one line, which is how a shelf label gets written. All 4 recompute the moment anything they depend on changes, and their results can be filtered and sorted like any other column. Then, the 2 properties that use AI. The first runs a prompt over every row and writes the answer into the cell. You give it an instruction, choose a model, and optionally point it at an attachment column to read. There are ready-made prompts for the usual jobs: summarize, classify, extract keywords, judge sentiment, translate, describe an image, or transcribe one. This column summarizes each piece for a gallery visitor from the note the curator wrote. This one was pointed at the photograph instead, so it describes what is actually in the picture. And this one reads the accession label and transcribes it, line by line, into text you can search. A column can be run for one cell, or for the whole table, and it costs a model call per row, so it is run on demand rather than constantly. The second AI property generates an image instead of text. Here it reconstructs each object as it might have looked when new. The result is stored as an attachment like any other, and it is generated from the row, so everyone is different. Worth saying plainly, a generated reconstruction is an illustration, not evidence, and it should never be filed as if it were a photograph of the object. The same table can be seen as a gallery, which is what you want when the record is mostly a picture. Filters narrow the rows by any column, including the computed ones. Show only the pieces in insurance band A, and the table answers immediately. Sorting works the same way on one column or several. A filter and a sort you use often can be saved as a named view, and you switch between views from the tabs. The unfiltered table is always one click away. Any row opens as a record, which is the readable way to see one piece with all 27 of its properties at once. Everything is editable here too, and it is usually where you work when a row has more columns than fit on screen. A table can be created straight from a CSV, with Nodus guessing a property type for each column and letting you correct it. Files can be attached in bulk as well, matched to rows by a code in the file name. That is how 40 photographs and 40 labels got here. And the whole table exports to CSV, Excel, or JSON, with the computed columns included as values. Search looks across every database in the vault at once. It searches the content of the cells, not just the titles, so a technique mentioned in one column finds the rows that use it. Analysis is where the tables stop being a list and start being data. It opens with a profile of every column, how much is filled, how many distinct values, the mean of each number. Underneath, a distribution for each column that has one, drawn from the real rows. And a correlation matrix across every numeric column at once, which is the quickest way to see what moves with what. Below that, you can run 10 named analyses by hand. Each one asks for the columns it needs and refuses the ones it cannot use. Descriptive statistics, count, mean, median, quartiles, spread, skew, and outliers, with a histogram and a box plot. Correlation between two columns, height against conservation hours. Bigger objects take longer to treat and the scatter shows it. The correlation matrix does the same for every pair at once, which is where a weak relationship stands out against a strong one. Covariance is the unstandardized version, useful when the units themselves matter. Chi-square asks whether two categories are related. Culture against material. They are, and the test says how confidently. A crosstab is the same two categories laid out as a table of counts, which is often easier to read than the test. Compare groups takes one category and one number, and shows how the number differs across the groups. Most frequent values is the plain question, what appears most often in this column. Time series needs a date column, and buckets the rows by day, month, or year. And data quality is the one to run first, not last. It reports what is missing, duplicated, or out of range before you trust any of the others. All 10 are computed on your own machine from your rows. No model is involved in the arithmetic. Where the AI does help is in choosing. It reads the shape of your data and proposes the analyses most likely to show something. Each suggestion comes with its reason, and running one computes it here from the real figures. And it can write the whole thing up. A report over the computed results, in prose, with the numbers it is describing. The division is deliberate. The model decides what is worth looking at and explains it. The arithmetic is never left to the model. Data chat is the last section, a conversation about the tables themselves. Ask which culture is worth the most on average, and how many of each are on display. It answers from your rows, and it is told to use nothing else, so it will say it does not know rather than invent a figure. The conversation can cover one database or several, and every exchange is kept in a history you can return to. It sees a sample of rows rather than all of them, so it is the right tool for a question about the shape of your data and the wrong one for an exact count. That is what analysis is for. 15 property types, 4 formula recipes, 10 analyses, and 2 conversations with your own records. All of it on one machine, over 40 rows of a museum catalog.